Hey everyone, how's everyone doing? Last talk, ready to go to the pub or home? Thank you very much for coming, for staying. We're gonna talk about how we managed to unify a bunch of security tools using emerging technologies and a tiny bit of code. And that's all. So, we pressed next twice, sorry. But before we say much, we need to discuss a little bit about the state of security today. Sal here really elaborated on this, but let me repeat and also state our position a little bit. These days, you cannot really, to achieve coverage, you cannot really just use a single tool. This is a problem. You need to use multiple tools. You need to scan code. You need to scan infrastructure. You need to scan binaries, laptops, endpoints, literally everything. There is lots of tools that each does something tiny, and they are all really good at doing one thing. And then you end up with a problem. You have islands, which is it's a single tool that does something very well, but they don't talk to each other. And what do you end up doing as a human, Andrea?
Yeah, so being there, done that last minute, so ending up writing a bunch of scripts to try to let me see if I'm actually impacted by this problem in this multitude of repositories and whatnot. And yeah, it can be very bad. And also having the false impression that once that's figured out, I can just hack it away inside my CI pipeline and then discover that I write something by accident and I bring down all the CI pipelines and CD for everybody and blocking production. So that's definitely not great, to go with. So, I mean, enough with the very gloomy things, so we can talk about something more fun. But first, who are we? So, thanks for coming and joining us today, first of all. My name is Andrea. I'm a founding engineer at Smithy. I joined Smithy about 4 months ago, not 4 years.
That would be cool.
And before that, I worked in the developer tooling team at Cloudflare. And one of the reasons why I joined Smithy is exactly to tackle these problems in security in general. Before that, I used to work in fintech and at Curve, if you're familiar with the company. I really like to work in DevX, so anything that really improves developer productivity or experience to me is great, especially in the platform realm. And I'm a Gopher at heart, so I really love Go. I think I've been working with Go for almost 1 decade now. And this is my colleague, Spiros.
So, hey everyone, I'm Spiros. I've been an open source developer, part of several communities for 18 years now. I started when I was much younger and had a much, let's say, more colorful view of the world. I've developed OpenCRE.org, which is the world's largest security knowledge graph, and lately, for a couple of years now, I wear literally all the hats at Smithy because Smithy started as some scripts I made in a previous job and kind of got out of hand, let's say. Same as OpenCRE.org, which is now European regulation. Who knew? But we're not here to talk about us. We are here to talk about OCSF. We've past the most gloomiest part of the presentation, that is kind of the problem that we went out to solve. So now we're going to talk a bit about unifying technologies. Luckily, there is a lot of technology out there that allows us to unify security tools. Problem is this technology is 4 months old. Some of this technology is Sarif, OCSF, an orchestration that is more than 4 months old. What we built on top of that, so Smithy, Andrea is going to talk to you how to build a component, give you a demo. I'm going to take it back with a bit of pitfalls, essentially how we messed up and how to backtrack, and then what next steps we totally promise to do, and some closing remarks. Hopefully all these will fit 25 minutes, so we can all go to the pub.
Okay, I can take it from here. So we can start by describing our unified technologies. So really we're looking into something to start to break the silos between all these different toolings and be really able to actually leverage the information from all of them in a way that makes sense without losing our heads, to actually give both to the inhabitant of silence, if it makes sense. So in our journey, we really explored initially this static analysis format called SARIF. You might be familiar with it because, for example, SNCC or GoSec give you the option to produce these findings in this format here. It's nice because it's open source, and it's really lightweight and easy to understand for both machines and humans. So it's really easy to reason about it. And again, it's quite very popular, I would say. The only problem with it that we found for ourselves, wanting to build a more precise platform on top of it, is that unfortunately it only maps to, again, static analysis. If we want to express different concepts in other realms, or we want to really start to build a real-time platform on top of it, SARIF is not the way to go. It doesn't really have a nice way to deal with concurrency when wanted to enrich findings or link things together, for example. And the schemas are nice because it still uses JSON schemas that you can generate your clients, but still the type safety is not there for what we want to build. So next, we explored OCSF. Okay, I said it correctly. I usually swap it for OCSF, OSCF, or whatever. It's an open source security schema framework. This is, again, an open source initiative and is maintained mainly also by committee. AWS plays a big part there. And OCSF is more younger, let's say. And the nice thing about OCSF is that it really tries to map multiple concepts. So not only SAST, that's why SAST+++, not just that, but also express, for example, how do I represent these kind of firewall problems into a format that makes sense, or these other extra formats. And let's say that also it's more opinionated and gives you more schemas on it, especially also for protobuf. And so you can get better type safety when building your platform on top of it. But most importantly, it's very extensible, which is also a con, and we can cover that because the learning curve is quite steep. But at the same time, you can represent with it even relationships between findings, or you can even enrich concurrently findings. For example, you found the same finding by multiple tools, 3 of them. They all mean the same thing. Okay, let me express it in a finding in OCSF. Here we can see an example of all the different categories that OCSF tries to map. Here we can find vulnerability findings, like firewall-specific issues. You name it, you have it. We're focusing only on vulnerability findings now, but we want to expand and take care of the rest also later. So this is a part of it. So this is the unification. So we can have now the common language that tools can use to report what they want to say, right? What is the second problem about this? It's how do we help people do the right thing? How do we help people not having to spend too much time into writing a bunch of scripts and then try to hack them into CI and see what happens, right? How do we connect multiple tools that are already present there? Usually this is a problem from my experience coming from lack of orchestration and being a separation between SREs or DevOps and the security team. And this means that usually the security tooling that is developed to take care of this is not really a first-class citizen. It's not treated as a production-ready and impacting system, even if it is, because often this can really block even releases and cause a lot of issues, right? So we try to take...
One thing on the orchestration. There is nothing that wakes you up better than getting a call on a Saturday night, 3 a.m., when a remote team cannot deploy to production to fix an incident because your orchestration or your bash script is failing and blocking everything, right?
Yeah, and this brought us to the next point, so in our journey, which was let's think about a way to solve this issue, right? Or at least attempt to do it. And it's let's try to use the existing tools, but kind of make them smarter and wrap them in a way that actually transforms that all of a sudden into a production-ready application, like any HTTP server that I will deploy in my production, in my cluster. Having out of the box, in instrumentation for observability capabilities like metrics, logs, traces, and handling even the most common cases or retries and lowering that noise, right? Making everything more stable. And most importantly, also not trying to like reduce the chances for you to have like very bad impact on production. Of course, this is impossible to bring to zero, but like we tried to do that.
So with all this technology that exists, OCSF that is very expressive and is now a Linux Foundation project, very young, but still, and a bunch of orchestration in our backgrounds on orchestrating things, we made an open source Smithy. Smithy is nothing more than a tiny SDK that speaks OCSF and a tiny binary that creates a workflow engine that allows anybody to run security tools and translate their output to OCSF. So you can now run scanners for vulnerabilities, dependencies, the dreaded SEA, or SAS, DAST, doesn't matter, translate it to a common format and create a data lake. The point of Smithy is that it allows you to fetch artifacts, so it downloads the complete parsers and components automatically. You can run the scanners. You can, because everything is on the same data format and creates a data lake as a byproduct, you can finally enrich results from any finding. It is the contextual vulnerability analysis a previous speaker was talking about. And if you can enrich, why not filter so you see less of noise? And finally, because you have a data lake is a swamp. It's useless without being able to report out of it, so reporting. If everything is on the same format, all of these things suddenly become trivial to do. So we built this. Because we build orchestration ourselves, instead of relying on something like Kubernetes or Tekton or any CI/CD, it runs natively anywhere you want. So locally, CI, or wherever you can orchestrate containers. We try to keep it as lightweight as possible. And that's it.
Yeah, so the core concept around it is that, again, we have the most smallest unit in Smithy is a component. A component is a concept that expresses like something that, like a piece of business logic that wraps the actual tool that you want to run, for in this example, truffle hog to sniff for secrets, right? And executes it in like a containerized way, and it's able then to take the results from it and parse them into the OCSF format. Not only that, but it can also leverage like previously known data that is persistent in a data store of your choice. Well, it has to be SQLite or Postgres in this case. But that helps you like try to understand, like, did I already find this issue before? Was it flagged by another tool? And by that you can take very interesting choices there. The components on their own, they are not very useful. Otherwise, we are kind of reinventing the wheel. But they are very powerful when they go and form a workflow. So a workflow is just like something, like it's literally a workflow formed by two or more of these tools. So again, you can have like a sample workflow like from here, where you can have like your cloning your GitHub repo. In this case, it might be like some Python repository because we can run a Bandit on it. But we could also run at the same time pip safety or truffle hog and various other scanners. And they will all do their job, and they will report all the findings in the same way through OCSF and persist them into the data store of your choice. Then after that, you can literally do any type of analysis on it, so any type of enrichment. In this case, there is an example for reachability. So this means that it doesn't really matter, like sometimes it doesn't really matter if your code is vulnerable if it's not reachable. You can take that risk. And you cannot work on everything at the same time, even if the tool says there is highest priority, right? And it's nicest to do like reachability analysis after that. You can do this because you can leverage this common knowledge, right? And then finally, you can filter the noise and you can actually report the issues wherever you want. Usually, like Jira is a famous, like a very popular destination, but it could also be Elasticsearch or you name it, you have it, right? To build your dashboards and take the decisions for your business. This is like how we configure a component. A component literally is like an OCI compliant piece of configuration. that kind of says, okay, please run this this tool that is running on this image. In this example, is like a GoSec. Run this command for me, and then please put your findings somewhere, and then please execute me the parser, which is built with the SDK, that goes and takes those findings and actually then has all the logic to do what I said earlier about instrumentation and also parsing the findings and persisting them into the database. And then the components are organized into workflow, which are, again, OCI compliant as well. And here you can see a very, like, an example composition for a workflow, which says, like, okay, I want a Git cloner component, then I want to run GoSec, add some annotation here, and for example, just log in into my terminal, like with JSON logger. Speaking about the SDK here is doing really the all the hard work because it's designed in a way that lets you really focus on only writing the business logic to, like for example, using a SDK to call like various APIs, and then you have to just like parse the data into OCSF. Then whatever else comes into like reading automatically from the database the findings related to that workflow run, or persisting everything to the DB, or reporting metrics, etc. It's done by it, so there is not really need to think about it. Usually this is the case for like really helping productivity for security engineers mainly, because they don't have the time to look into this historically. And just for context, it's written in Go because that's our expertise. But we have plans also to help, like especially with JavaScript and Python. We hear that a lot. Here we can write together like an example component. For those who are not familiar with Go, these are still like interfaces, like, and the important part here is literally like, okay, we want to write an example enricher. What does an enricher do? An enricher takes in input a series of findings, and then returns that series of findings with eventual annotations, which are enrichments. For example, this code is reachable, yes or no, or things like this code is duplicate, yes or no, right? And the orchestrator and the engine already takes care of this, and we just need to implement this bit. So here we can see a sample implementation for an Elasticsearch reporter. So basically this means that you can just like work on this piece of code, package it, how I showed you earlier with the component YAML, and that's pretty much it. As in, when this runs, the engine passes to it the correct findings that are relevant to that run. And then all you have to do is like parse these to, for example, JSON in this case, and then upload it to your destination, which is Elasticsearch in this case. As you can see, there is no other concerns here about like structure logging, monitoring, and actually reading and writing to the DB. When it comes to the orchestration, as we briefly touched on earlier, this can be done like locally or really whenever you want. We projected like Smithy to be able to run anywhere that you can like really rely on containers in, and the rest is not really relevant. In our case, we made it so that it can be just downloaded as a binary and just run locally in your machine as long as you have Docker. And then on CI is kind of the same story, right? But this also should raise some question about, can I run this on Kubernetes? And the spoiler is yes, and that's kind of what we work also on ourselves.
Spoilers.
And here there will be a very, very like small demo. I recorded this just because, you know, it's live, so bear with me. So here we write a simple workflow that maybe it has to start again, the GIF. I'm not sure. Let's go back.
Here?
No. I think it should start again now, I hope. Yeah.
How about now?
Yes, so here we're writing a workflow. It's a bit mixed, so you can see that various pieces. We're using both like manually expressed components and also components that are leveraging like that are coming directly from an OCI registry. And we are trying to scan a repository using GoSec and then try to put the findings both on the JSON logger and on Elasticsearch after adding a custom annotation. The custom annotation is not important here, but it's just to give you an idea that we could say, for example, this code is reachable, yes or no. And here, when you run the tool, you can see it in action. and it's literally like performing every step in the supplied order. So it runs first all the targets, then the scanners, then the enrichers, then the filters, and finally the reporters. Usually simulating what the proper pipeline does for this, for security. And this is kind of very new, so sorry for the bad output, but just to give you an idea here that we can see the final transformation in JSON that goes in Elasticsearch. And just to give you an idea on how powerful this is, so we run this concept. This is just to really express the fact that once you're able to build that normalized data lake, you can take very interesting decisions, right? Here we are showing that we run Smithy against like just running semgrep on repeat against the same repos. We run them against my previous company's open source stuff, so Cloudflare stuff. And here we can see that on every run for semgrep, we find, which is in green, we can find like multiple findings all the time. Whereas in orange, you can see the findings found by Smithy that progressively go and get smaller and smaller and smaller. Why is that? Because we are able to correlate the findings reported by different tools, and also we are able to find the duplicates and see also, is this actually relevant? Did I already raise this issue, yes or no? But we can do this only because we have this normalized data lake, otherwise we can't really do that. And it's showing that here we reduce the noise considerably by just taking this different approach, not run the tools in isolation, but rather putting them together so we're making them collaborate.
So security data lakes, I think we all agree, are very, very useful. But progress is not linear, sadly. We have taken quite a lot of detours, pitfalls, and backtracking to get here. So for anybody who tries to do the same thing or doesn't want to use Smithy, here's some advice. Essentially how we messed up. We started by using a custom API. Because why not? We know better than everyone else. So we started using a custom API, and we started with no SDK, because again, we know better than everyone else. And what ended up happening was every single extra tool that we added was an exponential more amount of work. Nothing tells you that your API is garbage until you have your protos, until for every new tool, you need to edit the API to have more fields and be more expressive. So we did that. We got burnt. We changed to OCSF. We're not going to change again because OCSF, as you saw, is quite expressive and makes sense. Another thing we did was at the beginning, we weren't very confident in our abilities to map data. We didn't know what the tool meant by having a specific field or who needs it. We weren't also talking to users as much as we are now. So by the way, Sarif does that too. We ended up having fields that said raw data or concatenating raw data from some random vendor or some random tool into a description or some human readable field. Sarif does that too, has raw data fields. Guess what happens? Everybody who reads that gets even more noise. Nothing tells you that the tool you're using is quite, let's say, immature until it dumps JSON in your nice description or your title or broken JSON in some human readable field for you to read and sort out. It makes a lot of sense. So which brings us to we learn from that we need to really be strict about original tool info. Less is more. Every single tool out there has a kernel of truth and a notion of noise because some vendor out there wants to sell more. And it makes sense. We take the kernel of truth out of the tools, try to map as much as we can, but you do not need to map absolutely everything. The random developer that will see your, for example, SAST finding does not need to know what version of Snyk this was produced by. Last but not least, because every single person talked about AI and we're not about to be different here, we spent about a month trying to map things with AI. All that code went to garbage because every single model we used hallucinated either on the source and would map random stuff or on the destination and would invent things that did not exist, never existed, which is great because it shows you that models are not there yet. It can help with the very basic, very high-level things, unless you train your own model, and we're not about to do that yet. So it can help you with the high-level things, but it will always need a human in the loop. And in the end, because human needs to be always in the loop, you end up spending more time than if you just copy-pasted and did it yourself. So now we have something that is a bit more mature, and it works. Today, we literally pushed version 0.6. It has execution engine, it has OCSF, it has helper methods. This quarter, we are planning on pushing out V1 as V1 matures. V1 has a lot more helper methods and shortcuts. It's mostly aimed at developers of components, so allowing people to integrate their own tools easier and faster. V0 has a community registry for components. V1 will have a community registry for whole workflows. Nothing says share the love than people publishing their own complete end-to-end workflows. So you can publish, you can discover, you can download components. Now, soon, you'll be able to do that with whole workflows. A workflow is OCSF, OCI. I get confused. All the acronyms. It's OCI, so it makes sense. SDK V2, sometime later this year, you're adding observability, I guess, and support more of OCSF as people are asking us for it. A very big candidate is compliance findings. OCSF supports compliance findings, and we're very big on compliance. Then it is a workflow engine. Everybody who ever made the workflow engine made it eventually Turing complete. So I think we need to. So adding more composable workflows, the ability to not only schedule producers and scanners and reachers and reporters, but schedule unlimited steps makes sense. We have submitted the talk for Hacker Summer Camp for LLM binding, so this is coming. We've committed now. And many, many more things as people ask us for it. We made Smithy, as I said, open source because we use community resources, and the only way to move forward is together. And to recap, because we're running out of time, please stop writing dirty bash scripts. Please stop using dirty bash scripts to support critical operations. It makes no sense anymore. Interoperability, the only way to do security properly is together, open standards. As I said, we open sourced Smithy because we use community resources and because we use mostly community resources. It makes sense. And the only way to move forward is with shorter feedback loops. Another reason why open sourced. If you make fast, tiny, fast and flexible integrations instead of 12 million lines of Java with classes and classes on classes so that you can create your data lake. Smith is open source. You can find it there. I promise that QR code does not lead to malware. So you can scan it or find that Smith security. Thank you very much. You can find the slides on this QR code. It is part of the same repository. And that's all.